Recently, front-end tooling is getting a lot of attention. It seems like everyone is working on something new. Snowpack was announced last year, but just released a V2. Evan You, the creator of Vue.js, is working on a tool called Vite. Even Jason Miller, who wrote Preact, just tweeted a few days ago that he's working on a similar tool. The one thing that all these tools have in common is that they are eliminating the bundling step from our local development environments. So what does all that mean, and why is it all happening now? Well, to answer that, we need to understand why we started bundling our apps in the first place. One reason we bundle our apps is for performance. In high latency environments like the browser, it's actually faster to send one large file over the network than it is to send many small files. But there's another more important reason that we still bundle, and that is because it enables us to write our application code using separate modules. You see, for most of its life, the web has only had one way to load script files, and that's with a plain old script tag. So if we wanted to load multiple JavaScript files, well, we just had to add multiple script tags to our pages. And we actually did that for a while, and it really sucked. And the main reason it sucked is because there's nothing that explicitly connects one script tag to another. That means that if we have one script that depends on another being loaded before it can run, we now have to manually order those script tags ourselves in a very specific order. Needless to say, this gets really hard really fast. But we still did it for a while. So this is where explicit module systems come in. Modules let us write code in one JavaScript file that depends explicitly on code in another JavaScript file using keywords like import or require. And once all the modules in our apps are using these keywords, there's a whole layer of tooling that can generate that final module order for us automatically and ensure that when our program runs, every file that runs after every file it depends on has already been loaded. This process is called dependency resolution, and it results in a module graph with all those dependency arrows pointing in the right way. And that's what lets us as programmers just write code that depends on other modules or libraries without even giving it a second thought. So resolving dependency graphs is one of the most important functions that these app bundlers do. Tools like Require.js and Browserify, and more recently Webpack. Now, modules in front-end JavaScript have kind of an interesting history. Like I said earlier, for most of its life, the web has only had one way to load JavaScript files, and that's with the script tag. But when Node came out, it actually created its own module system called CommonJS. CommonJS uses the keywords require and module.exports, which you might be familiar with. And because Node runs on the server, the way these keywords work is similar to how module loading works in any other server-side language like Ruby, PHP, or Python. Since the code that's being executed is on the same server as the other code it depends on, when the app gets to a point where it needs to load another module, the runtime can just stop what it's doing, load the other module by reading it directly from disk, and then pick right back up where it left off. This is called synchronous module loading, and again, it works because both the code that's running and the code in the dependencies live in the same physical location, and reading from disk is super fast. But the browser is different. It's a very unique runtime environment, and when we execute our application code, we're actually running it on our user's device. Now, those users' devices are very far away from the servers where our other code is being stored. So when our apps are running and they need to load a new module, well, the browser can't just stop doing what it's doing, go fetch the other module over the network, and then pick right back up where it left off, because fetching data over a network is way slower than reading files from disk. And this is exactly why, even though both Node and the browser run JavaScript, Node's CommonJS system could never work for the browser. It's just not suited to its asynchronous nature. So the browser needed its own module system, and this is where the design for the ES module specification comes in. TC39, the committee behind the JavaScript programming language, wanted to land a standard way to work with modules at the language level, something that would work with all implementations of ECMAScript regardless of the environment. And that led us down a long path to the ES module specification that we're all used to using today. Things like the import and export statements, default imports, named imports, basically the language that tools like Webpack understand and that we all write our apps in. And that's what this is all about. Once browsers understand import and export syntax, they can be the ones to look at our application code, follow the import statements, resolve that dependency graph, and do all of that work for us so that tools like Webpack don't even have to bother. And it turns out that this process of dependency resolution and constructing this module graph is actually pretty complex. And it's the reason why our Webpack builds slow down as our app grows. It's the reason why npm install is so complex and takes a long time. And the more we can offload this work to the browser, the faster our local development environments can become. So, how do modern browsers actually work with ES module syntax? I'm glad you asked. I got my laptop right here. Let's take a quick look. I've got a plain index.html file here with a single p tag. And right now nothing is running. If we look at this S command I have right here, we see it just runs this Python simple HTTP server. And so it just serves up all the files in this directory. And so once we run that, we can just request files just like a normal web server is able to do. And so we're not running any build tooling here. We're not running Node or Webpack or anything. This is simply a web server serving up files. Now let's drop a script tag and write console log hello world. And if we come over here to our browser, open up the console here and refresh, we should see hello world right here. So this is normal JavaScript. Let's call this a classic script because this is just kind of the standard way that JavaScript is loaded. Now there's some interesting things about classic scripts. If we log out, this is, and then we write the this property, we'll see that in classic scripts, this points to the window object. And that's actually because classic scripts share the same scope. So if we were to write another script here, and in our first script, let's say let x equals 1, and in our second script, we'll just log out x. We're going to see 1 here, and this is from the second script. So we see here that classic scripts share one context, and they also have the this property defined to point to window. And then lastly, if we were to try to do something like export default some string here, and reload this, we're going to see the JavaScript engine throwing an error that says unexpected token export. So those are some characteristics of classic scripts. Let's just refresh here and see this working again. So now let's talk about ES modules. The way we tell the browser to work with ES modules is just by adding a type attribute called module. If we save that and come back, check it out. We are getting an error from the second script that X is not defined. So one of the first differences here between modules and classic scripts is that modules actually have their own scope. This is pretty neat because before modules in JavaScript, we only had function scopes, and then let introduced block level scoping, but loaded scripts like this always still shared a scope. But now with modules, they actually have their own isolated scope. So this is kind of neat because this is actually a new scope in JavaScript. So we see here that X can't be shared across these two modules. Another difference we see is if we try to log this, we're going to see undefined. So the this keyword is undefined within modules. Now we still have access to the window global within a module, but this is undefined and modules are scoped. And finally, if we were to write export default some string, and come back and refresh, look at that, we don't see any errors here. But of course, exporting and importing is really most useful when you have separate module files. So let's go ahead and turn this into an actual file. We'll just create an app.js file right here. Copy this over here. I'll put this down here below. And right here, we'll just use the source attribute like always to reference our file here on the file system. So down in our app, let's just add a console.log hi from app. And now when we reload, our browser is fetching app.js and executing it. So we see this is all working. And if we were to take out the export and take out the type module and run this as a classic script, this will work exactly the same. This is kind of how it's always worked. But these module scripts enable the import and export statements to actually work. So let's create another file called source favorites.js. Go ahead and close the terminal. And in favorites, let's export a const of color equal to blue. And in app, let's import color from ./source/favorites. And then we'll just console.log. My favorite color is color. So let's save this and refresh our browser and take a look. So our browser is loading app.js just like before. And we also see it's making a request to source/favorites. And it's getting a 404. And if we come and look at our terminal here, we're going to see that we got a 404 because the file source/favorites was not found. So this is the first thing you'll notice about ES modules in the browser, is that the browser is actually going to treat this import path as a URL. And so it's literally just taking this path right here and converting it to a URL. And because we don't have anything called favorites here, it's 404. But if we were to change this to favorites.js, come over and reload this, look at that. We're loading app.js. App.js is loading favorites. The module export works, and we get my favorite color is blue. So this string right here in the ES module specification is called the module identifier. And in the code that we're used to writing, we usually write it without the extension, right? This is kind of how we're used to writing module imports in our applications. But the browser treats these module identifiers as URLs. So that's one of the main differences here with how browsers handle ES modules. And it's also one of the things that these new build tools do, which is to rewrite our existing import statements into URLs that the browser understands. That way we don't have to rewrite our existing code, and our existing tools work as well. But this is pretty neat. Once we use a URL right here, it's pretty cool that the browser is able to follow this. So basically the browser has two ways to load modules. One is with a script with type module, and the other is with an import statement. And an import statement can only load modules. It can't load classic scripts. So the browser will always parse these includes as modules. And that means if we were to do something like try to log this is this from our favorites file, then we should see undefined, and we do. So let's do it again. Let's come here and maybe we'll make something like a utils/add.js. And we'll just export a default function that takes in A and B and returns A plus B. And over in favorites, we can import add from /utils/add.js. And let's just console log the sum is add 2 and 2. So we should see the sum is 4, and we do. And there we see our add module being loaded by the browser as well. Now, because these module identifiers are URLs, they can be absolute URLs too. So we can drop the ... and just put a leading slash here to hit the root of our web server, which would be the root of this directory right here, since we're serving from that root. And if we save that and reload, we should see that everything is working, and it is. And what this means, because these can be relative or absolute URLs, they can actually be URLs from other domains as well. And this is one of the places where this Pika tool fits in. So if you go to pika.dev, you'll see that they have a CDN here for packages. So if we were to come and type in Lodash, we can come down and see that there's a package called Lodash ES with Lodash exported as ES modules. And right here, Pika gives us this import path. So we can just copy this, come back to our app. And let's just comment this out and paste this inside. we'll see that this is cdn.pika.dev. This is a full URL, and it even has a version number here. And this is Lodash, so we should be able to import add from Lodash. And let's change this to 3 and 4. Save that, refresh. Check that out. The sum is 7. Our browser is fetching Lodash-ES, the version number, and then another build that's provided by Pika. But you can start to see how all of this works. As long as whatever is being requested from our browser is an ES module, then our browser is able to figure all these dependencies out, fetch them and load them and execute them in the correct order with absolutely no build tooling running at all. Even if we were to come over here, copy this import, come up to our app, add another log that says, let's add from app, and then we'll call add 5 and 5, refresh our browser, we're going to only see Lodash being loaded one time here, even though our cache is disabled. And that's because when the browser is traversing all these import statements and building up that module graph, it also has a cache so that it doesn't unnecessarily request the same module multiple times. And it works even if we use our own modules here. So if we delete this and go back to importing the add straight from utils in both places here, save that and reload, we're going to see add is only requested one time. So hopefully you see how cool this is, and the fact that this new wave of build tooling can actually leverage all of the information that the browser is providing through these module graphs, again, to offload so much of the work of resolving the dependencies off to the browser and to save us from having to do that work at build time on our local computers. Not to mention that the browser does this lazily, so none of this work is happening until we visit a page that loads a module via a script tag and the browser starts requesting that entire graph. So you might be thinking, well, great, this seems to work fine for these 3 modules. My project has hundreds of modules. Wouldn't that be impractical? Well, especially in production, we wouldn't want our users, who again are in a high latency environment, to have to load 600 individual small files. But when we're developing locally, latency is usually not the bottleneck. In fact, it usually never is. It's always how long our compilations take and rebuilds take once we change a file on disk and wait to see the changes. But in an environment like local development where latency is not an issue, we have a really strong internet connection most of the time. Delegating all this work to the browser to be done lazily will save us a bunch of time up front, which is why the cold start times on some of these build tools are basically instant. And they also support hot module replacement out of the box because they're just going to swap in new modules to the slot in the browser's module graph whenever something changes. So hopefully you can start to see some of the optimizations that this architecture enables and just how much it can simplify and speed up our local development environments by delegating all this work to the browser. Now, there's still a lot of work that's going on to make the massive amount of code that's on NPM available to modern browsers that know how to load modules, but the future is very bright. Browsers are really good at fetching and caching dependencies. And so I think, starting today, but definitely over the next few years, we're going to see this pattern become very prevalent in our local development environments. So I hope you found that informative. There's a lot of moving pieces to this story. It's pretty complex. So if you have any questions, just leave me a comment. Thanks for watching, and I'll see you in the next video.